Hi, Algebra 2 honors students. Today we'll be going from standard to vertex form in a quadratic equation with the general case. Okay, in class we did a couple of examples of going from standard to vertex form using particular problems. Today we're just going to sort of prove the general case, how you go from standard to vertex form, and in so doing, figure out a formula for the vertex that uses the coefficients A, B, and C. All right? So, as you guys know from class, the first move is to sort of rope off the first two terms, right? The quadratic and the linear term from the constant term. So first thing we do is just separate those two terms, all right? Now, as you know, we next factor out the A value. Whatever A is, we take it out of the first two terms. So in doing so, we've got to be careful. A times x squared will give us ax squared. Now, for the bx term, it would be b over a x that would give us the next term, right? Because a times b over a would just be bx, right? Plus c, okay? So, that's where we are right now. Now we do the completing the square step. So, we add half of the middle term squared. Okay, half of the phone, I guess we'll have to wait. Half of b over a will be b over 2a. Okay, half of, just real quickly, half of b over a will result in b over 2a. But then we've got to square that to figure out how to complete the square. So b over 2a squared is b squared over 4a squared. This is what we've got to add to complete the square, okay? B squared over 4a squared. All right? So again, I showed how I got that down here, right? I took half of b over a and then squared it. Right? Let me erase that. I don't have an eraser, so I've got to get a little messy. Okay. So we're now this step. We have plus c. But remember, guys, that when we add inside here, whatever we add inside here, we have to multiply by that a value and then do the opposite to the end, right? Because we're only allowed to add 0. So by doing this, we've got to take away something from the end. We've got to take away the product of a times b squared over 4a squared. So multiplying a times b squared over 4a squared, the a will cancel out with one of those two, and we're left with b squared. Whoops, shouldn't go there. We're subtracting b squared over 4a. Okay? Look, guys, this part's going to get a little messy. That's not a very big part of my concern. This is going to end up being the y value of the vertex. Okay? We're really going to what we're going to focus on is seeing what the x value of the vertex looks like. The y value is a little bit messy. So if you don't understand when I collected these terms later, it's okay. All right? But as you guys know, after we complete the square, we now factor. So what we're left with is when we factor, don't forget that when you complete the square, say like x squared plus 10x plus 25, right? The way that factors is always x plus 5 squared. It's always x plus whatever half of the middle term was squared. So here we have x plus, what was half of b over a? b over 2a. Like what was half of 10? 5, right? X plus 5 squared. So this is going to factor into x plus b over 2a squared, all right? That's the really key part of this whole problem I wanted you to see. For this stuff, guys, just to remind you, to add fractions, we need a common denominator. So let's do this very quickly. It's okay if you miss part of this. C we have to write as, we have to have the denominator of 4a. So it'll become 4ac over 4a minus b squared over 4a. So, all right, it's going to end up being 4ac minus b squared over 4a. All right, it's a little bit messy, but that's going to be the y term. But what's most important, guys, is the x value, okay? So this is the vertex form of the general case, this. And again, the y value is messy. So yes, I mean, remember the vertex form? I'll write this all the way down here. The vertex form of a quadratic is y equals a times x minus h squared plus k. So now look at this. These two should match up, right? The vertex is at hk. So to find the k value, to find the y value of the vertex, we could just use a, b, and c and plug them into this expression, and that would give us the y value of the vertex. That is true. But this is a really messy thing to memorize, so we really don't want to do that. But the easier part is the x value, okay? The opposite of b over 2a, or because these signs are different, it is the opposite of b over 2a, because this is like shifting left b over 2a units to get to the x value of the vertex. It's a very nice little formula, okay? The opposite of b over 2a is going to give us the x value of the vertex. So if you have standard form, you can find the vertex pretty easily. Yes, you could go through the completing the square process in order to go from standard to vertex form, but you also could just take the opposite of b over 2a to find the x value, and then just plug in that value to find y. Right? One quick example, right? Like, let's say the problem was y equals 3x squared minus 12x plus 7. All right? If that was your equation. Yes, you could factor out the 3, complete the square, and so on and so forth. But there's a little formula. This, actually, I should write h. Okay? The x value of the vertex. The x value of the vertex, h, can be found using the opposite of b over 2a from the original problem. That's what this proves. Okay? So all we've got to do is take the opposite of b. So the h value of the vertex is going to be the opposite of b, so positive 12, over 2 times 3. So 12 over 6, which is 2. So h is 2. So the x value of the vertex is 2, and now we can just plug that in for x to find the y value. All right? So the purpose of this, again, was just to sort of remind you about the steps you can use to go from standard to vertex form using completing the square. But just as importantly is to derive a formula, which is the opposite of b over 2a, to find the x value of the vertex. Okay? The x value of the vertex is the opposite of the b value in the standard form over 2a. Okay? So let's just finish this up. So knowing the h value is 2, again, we can plug this in quickly to get k. 4 times 3 is 12. Minus 24 is negative 12, plus 7 is negative 5. So now we can easily get the vertex form. Y equals, the 3 is still going to be the 3. H is 2, so x minus 2 squared minus 5. That is going to be the vertex form of this. And I did that much more rapidly than having to complete the square and everything. Okay, just knowing the formula for the x value of the vertex. All right? Thanks.